Hi everyone, welcome to my channel. Now in today's video we are going to discuss the topic of horizontal projection. Okay, this is in continuation with the topic projectile motion. So horizontal projection, इसका क्या मतलब होता है? Horizontal projection means from a height. Suppose I am projecting this chalk from this height in the horizontally. Okay, so the velocity is given in the horizontal direction, that is parallel to the floor. So this is the floor and I am projecting this chalk parallel to the floor. So it is going in the horizontal direction, but it cannot go forever because gravity will act. So this chalk will take this path. Okay, it will fall like this. So suppose from this height, suppose this is a tower. Okay, and this is the ground. This is the horizontal ground, and this is a tower of height h. Okay, from this point the projectile is projected horizontally with velocity u. Okay, and because of gravity it takes this path. So this is the path of the projectile under the influence of gravity. So this path is called trajectory. Okay, so this is the foot of the tower and this is the point at which the projectile strikes the ground. So this distance is called horizontal range. Horizontal range is the distance from the foot of the tower. Okay, so suppose this is the tower, so this is the foot of the tower. So from this point to this point, the point at which the projectile hits the ground, that distance is called horizontal range in this case for horizontal projection. Okay, so this is horizontal range. Horizontal range. Okay, Asha. Now suppose in this case again here motion is taking place in a plane. Why I am saying that motion is taking place in a plane? Because this is x-axis, this is y-axis, horizontal direction is the x-axis, vertical direction is the y-axis. So when the projectile starts its motion, it is at this particular position. So it moves from this point to this point. So while coming from this point to this point, suppose this is A and this is B, this is C. Okay, so while moving from A to B, if horizontal direction is x-axis, vertical direction is y-axis, so at each and every point its x and y coordinate will change. Okay, so to define the position I need two coordinates. Okay, so that means motion is taking place in this plane. For this case, plane of the board. Okay, so this is an example of motion in plane, or we can say motion in two dimensions. Motion in two dimensions. Okay, x-axis and y-axis. So the equation of motion, see again here the projectile is moving under the influence of gravity, so it is moving with constant acceleration. Acceleration is constant. So since acceleration is constant, we can use the equations of motion. Okay, earlier also I have told you that these three equations of motions can be used only when acceleration is constant, acceleration is uniform. Okay, so we have this equation s equal to ut plus half at square. Okay, see basically just by looking at this you might have it might have struck to you that I am going to derive the equation of trajectory. See, whenever we have to derive the equation of trajectory, that means we have to find a relation between x coordinate and y coordinate. Okay, x coordinate and y coordinate. So now this is the general equation of motion. Now here motion is taking place in two dimensions. Two dimensions means along x-axis and along y-axis. So I can break down this equation in two forms, that is for motion along x-axis. For motion along x-axis, this is displacement. So here we have displacement along x-axis is equal to ux, initial velocity along x-axis, into t plus half ax. A is the acceleration, so this is acceleration along x-axis, t square. Now similarly for motion along y-axis, motion along y-axis. I can write this is displacement, so I will have displacement along y-axis y. This was uxt, initial velocity along x-axis. Here you will have initial velocity along y-axis plus half ay t square plus ay t square. Okay. Acha, this projectile, when it comes from this point to this point, see, gravity, it is acting in the vertical direction. There is no force acting in a horizontal direction. For projectile, we say that projectile is a body which moves under the influence of gravity. Okay, and gravity acting in the vertical direction. So here there is no acceleration. There can't be any acceleration along horizontal direction. Parallel to the ground, there can't be any acceleration. So we have ax is equal to 0 and ay is equal to g. Ay is equal to g. Okay. Acha. Now here I will write ay is equal to plus g. I am not going to write minus g, because in this case I will take anything which is in the downward direction as positive. Okay, so that convention you can take, that is, there is no harm in that, but you have to define things which are in the same direction, they are positive, things which are in the opposite direction, they are negative. That is one way of understanding. The other way of understanding this is, see, when the projectile comes down, obviously it will undergo acceleration. Only while going upward it will undergo retardation. So here the projectile is coming down, so there is acceleration. So this x is equal to, now what about this? See, this is horizontal direction, this is x-axis. This initial velocity is along x-axis, so ux, it is equal to ux, initial velocity along x-axis, it is equal to u, because this velocity is along horizontal direction. This is y-axis, this is y-axis, this is 90 degree, this is 90 degree. So if this is u, this is 90 degree, so this will be how much? U cos 90 degree. This will be u cos 90 degree, and this is equal to ui. Ui is u cos 90 degree. Cos 90 is 0, so that means this velocity will be 0. So ui, it is equal to 0. Okay, so we have initial velocity along x-axis as u, initial velocity along y-axis as 0. Okay, so this is y-axis. So initial velocity along x-axis, this is the initial velocity along x-axis, and this is the initial velocity along y-axis. So let us make this substitution over here. So x equal to u into t plus 0. Ax is 0, so this term is 0. So t is equal to x by u. T is equal to x by u. Okay, acha. How about this? So y is equal to 0 plus half gt square. Uy is 0, so this first term becomes 0. So y is equal to half gt square. Okay, y is equal to half gt square. So if this t is substituted over here, t from this equation is substituted in 2. T from 1 is substituted in 2. So what do we get? We get y is equal to gx square divided by 2u square. Okay. Now here, this term g and 2u square, it is a constant. So this is of the form y is equal to ax square. Y is equal to ax square. So this is the equation of parabola. This is the equation of parabola. So this equation y is equal to g x square divided by 2u square. This equation represents the equation of the trajectory. Okay, why I am saying that this is the equation of the trajectory? Because if g, 2u, these things are constant. So if these things are constant, suppose it is equal to 5 or 6 or whatever. So y is equal to suppose 6x square. So if you substitute different values of x, you will get different values of y. And if you plot all those values, you will get this curve. You will get this curve. So that means this is the equation of the trajectory. Equation of trajectory. equation of trajectory. And since this equation is of the equation of parabola, so that means the trajectory is parabolic. This path is parabolic. Okay, trajectory is parabolic. Okay, so this is the first important observation with regard to horizontal projection. Achha, next, if we have to find the time of flight. So in this case, time of flight is the time taken to travel from A to B, isn't it? So time of flight. See, when it is coming from A to B, what is the displacement along y-axis? How much is the displacement along y-axis? H, isn't it? So if we use this equation, y is equal to half gt square. Now time of flight is suppose capital T. Now this is this equation, y is equal to half gt square. Now if I replace this y is with h, y with capital H, that is the displacement along y-axis when the projectile travels from A to B. So this will be equal to half g capital T square. Means when y is equal to h, small t is equal to capital T, isn't it? So from this we have t is equal to square root of twice h by g. Twice h by g. Okay. Now this is a very interesting result. Why I am saying that this is an interesting result? Because see, as you can see, time of flight, it is equal to square root of twice h by g. So that means time of flight is independent of velocity of projection. It only depends on height. So from the top of a building, if you throw stones with different velocities in horizontal direction, all these stones will reach the ground in same time, because time is dependent on h. Time is dependent on the height. Okay, it is independent of velocity of projection. Okay, so t, time of flight, independent of velocity of projection. Okay, it's a very important thing. Time of flight is independent of velocity of projection. It only depends on the height from which the projectile is projected. Okay, this is for horizontal projection. Okay. Achha, next we will calculate this distance r, that is the horizontal range. Okay, horizontal range, it is the displacement along horizontal direction, isn't it? Maximum displacement along the horizontal direction. So if we take equation along horizontal direction, x is equal to uxt plus half axt square. This is the displacement equation along x-axis. So obviously this term will be 0 because acceleration along x-axis is 0. So we have x equal to ux into t. Okay. Now this is the general displacement. But if the projectile travels from this point to this point, the displacement along x-axis is r. So that means if this x is equal to r, ux, what is the initial velocity along x-axis? It is u. Okay. And what is this t? This t will be the time taken to travel from this point to this point. That is equal to the time of flight. So into t. So this range becomes u times square root of twice h by g. So this is the expression for horizontal range. Okay. Achha, next, suppose we have to find the instantaneous velocity. Okay, instantaneous velocity means velocity at a particular point along the trajectory. Okay, now this I have told you already that for projectile we have the trajectory. At any point, if you wish to find the direction of velocity along the trajectory, at any point on the trajectory, if you wish to find the direction of velocity, at that point you draw a tangent. The tangent will give you the direction of velocity. Okay, so suppose you have to find the direction of velocity at this point. So what we will do, we will draw a tangent at this particular point. So this is the tangent. Okay, so this is the tangent. So this is the direction of the velocity. This is the direction of the velocity. Okay, Achha. Now I can resolve this velocity into two components. This is the horizontal direction. Suppose this angle is alpha. So this is Vx and this is Vy. Okay. So this V, this is the x component of velocity. This is the y component of this velocity. Okay. Alpha is the direction of velocity. Direction of this velocity. Alpha angle with the horizontal. Now obviously Vx, it is going to be equal to u. Vx is going to be equal to u. Why? Because Vx is equal to ux plus ax into t, where t is the time taken to travel from this point to this point. T is this time. Okay. Achha. Now acceleration along x-axis is 0, so this term is 0, and this is equal to u. Ux is equal to u, so Vx equal to. Okay. Similarly, Vy is equal to uy plus ay into t. So Vy is equal to uy, initial velocity of y-axis, it is 0. So this is 0 plus g into t. Acceleration along y-axis is g. So Vy is equal to gt. So we have Vy, we have Vx. So what is the value of magnitude of V? Magnitude of velocity. It is V equal to square root of Vx square plus Vy square. Correct? So V is equal to square root of u square plus g square t square. So this is the magnitude of velocity. But velocity is a vector quantity. So in addition to magnitude, we also need to find the direction. So direction of velocity. So direction of velocity, that is this angle. So what is the value of tan alpha? Tan alpha. If you take this triangle, this tan alpha, perpendicular by base. Perpendicular means vector Vy. So tan alpha is equal to Vy by Vx, or alpha is equal to tan inverse Vy by Vx. But what is Vy? Vy is gt. So tan inverse gt by u. So from this you can find the direction of velocity. Okay, so this is how you can calculate the instantaneous velocity. Instantaneous velocity, that is velocity at any arbitrary point along the trajectory.